Good morning to everyone. My name is Sritharshini from 3CSCA. Today I am going to say about breadth first search from AI. So my topic is about breadth first search from artificial intelligence. So now let us see about breadth first search. Breadth first search is also known as BFS. The BFS expands all the states one step away from the start state and then expands two steps away and then three steps away and so on until the goal state is reached. So as it is given, BFS expands the corresponding state of one state and that corresponding state is expanded. So until the goal state is reached, the states will be expanded. Which are its corresponding states. For example, if we take one and its corresponding states are 2 and 3, the first it expands the 2 as one corresponding states are 2 and 3, it expands 2, and the two corresponding states are 3 and 4, it expands 3, and then 3 corresponding states is 9 and 10, it expands 10 until the goal set is reached. It expands the next states of that state, and after completing at a certain state, it moves to the next state and it again expands that state. So BFS expands all the state one step away from start state and then two steps away from start state and then three steps away from start state and so on until the goal set is reached. So BFS gives the optimal solution. BFS uses two types of list, open list and closed list. Open list is of queue and closed list is of stack. Open list contains the states which are to be expanded. The closed list, which is a stack, will be containing the states which are already expanded. So BFS gives the optimal path, and in BFS we use two lists. They are open list and closed list. Open list is of queue and closed list is of stack. And queue as open list, which is a queue, contains the states which are to be expanded, and the closed list, which is a stack, contains the states which are already expanded. So this is about BFS, and now let us take the water jet problem. What do you mean by water jet problem is, suppose there are two jugs. Suppose there are two jugs of different quantities. Suppose let me take as one jug is of 5 liters and another jug is of 3 liters. And the result I want is I should get 4 liters of water. So to get 4 liters of water, there is some method to do by BFS. By using BFS, we can get the 4 liters of water in 5 liters of jug. So let us, for example, BFS is implemented to check whether the goal node exists or not for water jug program. So let us see the algorithm. So first, input is start and goal states and local variables open, closed, statex, and successor and found. Local variables are those, and output is yes or no. Yes or no, it means that the goal state is found is yes, if not found it will be no. So method is first initialize the open list and open list with start and close it is 5. So first initialize the open list with start and close it with 5. Then open found equal to false. While open is 5 and found is false, when those two conditions, open is 5 and close is found is false, these two conditions satisfied, we enters the value. Then do that. Remove the first state from open and call it as state x. The state which is in open, remove that, and that state is called as open state x. And put state x in the front of closed list. Closed list is a stack, right? So x is now we are using. So x is stored in a closed list. So state x is stored in a closed list. As closed list contains the states which are already used. So now we are using, so it moved to the closed list. If stat x, if state x equal to goal, then and then found equal to true. State x, if the state x which we taken is the goal state, then found is true. If not, if it is not a goal state, then perform expand operation. So that state corresponding states will be checked and it will be expanded, producing a list of successors. Which are the successors of that state will be expanded. Now remove from successor those states, if any, that are in closed list. If the closed list contains the states which are or the successors, remove them and keep it them in open list. Append successors at the end of the open list. As I said, the successors which we removed from closed list will be added to the open list at the end. So this process will continues until the open until whether the state x is goal state, then will be true, or else found is found is pi. Sorry, open is pi and found is false. So if these conditions don't satisfy, then it will skip the while loop, and if found is true, then return yes or return no. So when we found that state x is a goal state, then we'll return it as yes. If we didn't found that, then we'll return as no. So by this, the algorithm BFS can be done for waterjet problem. So let us see waterjet problem in BFS. So first, the 00 is the 1 liters or 0 liters object, 5 liters object and 3 liters object. Initially, there is a no water in those two lakes, so 00. So first, let me pour 5 liters. First, let me fill the 5 liters object with water. So 50. Or else, let me fill the 3 liters object with water. 3 So first, let me see 5 and 50. So 50 is can the possible outcomes can be of 00 or 0 or 2 3 or 5 3. So as 00, if we take 00, it will be an initial state. So if we take 5 3, the next state will be of 0 3 or 50 or 0 3. That's it. So 0 3 or 5 3 is already existing state, so we don't take that. And next 2 3. If we take 2 3, the possible outcomes can be of 0 3 and 20 20 or 50 and 0 3 are already existing, so 20 is taken. Next, if we take 0 3, the possible outcomes can be of 5 3 and 0 0 and 30. If 5 3 and 0 0 are already existing, so we don't take those, and 30 is the new state, so we take 30 and we expand that. And if we do the same process similar to that, at last find the goal state at 50 23 20 02 and 52 and finally 4. Finally, I need a 4 liters of water, so where we got 4,3. 4 liters of water is present in 5 liters of jet. So by this, we can get the optimal solution by using BFS. BFS is when one state is taken, it expands all the corresponding states, and that state is taken, it expands all corresponding states, and this is taken corresponding states, this corresponding states. So like this, the corresponding states are expanded. So this is the BFS, or we use waterjet problem by using the BFS. So let us see in descriptive. At each state, applicable rule is applied. If it generates one of the previous state, cross it. If new state is generated, expand it in BFS style. So as we see that 5003 and next state it's 23. 23 is a new state. So it is expanded in BFS style. A path is visible from start to goal state by tracing the tree in reverse through parent link. So when we find the goal state by reverse through the parent link, we can get the path. optimal path is optimal and most shorter path is not there. So BFS gives, as we already know that BFS gives the optimal path. So path is optimal and more shorter path is not there. So solution path can be 00502320025243. See here the solution path is 00502320025243. So this is the shortest path for this. This is about the breast first breadth first search in AI.